Okay. And then I'll go to, now, here start the apologies. Okay, sorry about this, folks. Until fairly late yesterday afternoon, we had been out of country for about 9 days. So I was not here at all yesterday, and I thought, my wife said she'd have her tablet and I could do anything I wanted to while we were done. I didn't have lots of time, but I did. It would not let me because it's a Microsoft product. These are all, it's a Apple product, and this is all Microsoft. I could open them, I could see them, but I could not work on a single file. It just would not let me do it. Of course, I was going through Blackboard, and that probably messed it up too. But this is our syllabus for the course. Not the one for this term. This is the one that we used last fall, okay? But I'll tell you the differences. The crucial stuff isn't anything changed. It's just the dates and things like that have changed. I'll try to fill you in on that. Okay? It is now summer 2018. Math 238, Applied Differential Equations 1. 3-hour course. Of course, in the summer, it's going to be closer to 4 hours because it's only a 10-week term rather than a 16-week term. And the class meeting times are different from this. It will be Tuesday, Thursday, 8 to 9:50. Okay, here in this room, this building, Bessemer campus. Okay, my name is Charles Fowler, and my contact policy, they call it, strange thing to call it. Here's my email address. And by the way, just about every employee of the college is first initial, last name at lawsonstate.edu. But as you might guess, we have more than one S. Williams. Okay, so I know that one for a fact. And therefore, some will have 2 initials and a last name at lawsonstate.edu. I'm the only Fowler here, so it's just C. Fowler at lawsonstate.edu. There are a few individuals that have modified it in some way, like one of our speech and English instructors is Calvin King, and he chose to do Calvin-King rather than K. King. I guess you can do that, no problem. Okay, here's my phone number. And for the summer, this is the one that's going to matter, 929-3449. Fridays only, I'm on the Birmingham campus, it's 929-6409. Okay? Now let me tell you something about, start off, let's go back to email for a minute. Because I have been out of pocket for almost 2 weeks, okay, not quite 2 weeks, 9 days, I am way behind on emails. So if you have emailed me recently and I haven't responded, that's part of the reason, okay? When I will get caught up, I don't know, because when you see later what my schedule's like this summer, I'm going to be in class almost all the time. So it's going to be hard to catch up on emails, okay? Now, this Friday thing, okay, let's go to phone. I hate to say this, but please don't call when I'm in class, because I can't hear the phone ring, and sometimes my voicemail works okay, and sometimes it doesn't, and I'll never know when it may be missed, because it just isn't that reliable. So when you see my office hours, then try to call during office hours. If you can't catch me then try again a little bit later. Now, Fridays, don't ever leave a message to that number, because that's not my phone number. It's the a grant, let's see, what do they call it? A grant coordinator's office Monday through Thursday. And since she's not there Friday when I'm on the Birmingham campus, that's where they put me. But if you leave a voicemail, I can't access it. She can, and she'll say, what in the world is this? Okay, so don't ever leave a voicemail at this number, only there. But here's the other deal about Friday. Can I help you find something? I'm sorry? This is differential equations. Okay. What are you looking for?
You told me to find another. I 103.
Okay. Well, Bio 103 is down at 259. Yeah. It's going to be like that probably all day long. Okay. Sorry. But I I will be on the Birmingham campus Friday, this Friday, so call me anytime there. That's tomorrow, by the way. As far as I know, I'll be there. Unless they call a meeting out here, then I'll be out here. Okay, so that's tomorrow. Beginning then in June, even though tomorrow, is that the first day of June? No. Next Friday is the first day of June, and I think we still are open that day. Okay? So I'll be on the Birmingham campus that Friday as well. Next Friday. But then for the rest of June and July, we're on a 4-day work week. Okay? 4 10-hour work days rather than 5 8-hour work days. So therefore, this number won't be any good after this tomorrow or next Friday for me, okay, until August. And we do have like one Friday, I think, or maybe 2 in August, and we'll be back on 5-day schedules. We're only 4-day schedules, June and July. Even though next Friday is the first day of June, we still need to be there for some reason. Okay, so that number will only be good this Friday, next Friday, tomorrow, next Friday, and then whatever Fridays we have in June, and in August. Okay, my office hours. Okay. I wrote these down while I was overseas, and they got all crumpled up. So let me tell you what they are right now. On Mondays and Wednesdays, I have Calculus 1 from 8 to 10:40. That's a 4-hour course. It goes even longer. Okay, so I have 20 minutes from 10:40 until 11 o'clock. And then I have Calculus 2, another 2 hours and 40 minutes, so that'll be from 11 to 1:40. Okay, and I have another 20 minutes between 1:40 and 2 o'clock. Now this may change, okay? My physics class is not all that populated now, so we may have to combine these to stack them, the Physics 202 with Physics 214. Same physics, just different math levels, and we teach that like that fall and spring, but usually in the summer we have enough students with transient students, or I know you're a transient student, so we get transient students in, and usually I'll fill all 4 sections of physics, and then I teach it. But one of these classes, I believe it's a 202 class, was a bit on the short side, so we may have to stack that with Dr. Bryant's 214. If so, then I may have some office hours between 2 and till the rest of the day. That was sort of a surprise for me because most of the time that works. Well, no, let me back off from that. 2 until 6 o'clock. The 201 looked like it is big enough to make on its own, so that means I may be here from 6 until 9:30 on Monday and Wednesday evening. So I have a big chunk of office hours if we don't get any more students in the Physics 202 from 2 until 6, it looks like. I'll get all this worked out when we see how the numbers pan out. I think drop add was yesterday and today, so the schedule should be pretty much fixed as of at the end of the day today. All right. Then on Tuesday and Thursdays, the days y'all are probably going to be on campus, I thought I was just going to have this class in the morning from 8 to 9:50, and because even when I was overseas, I could see, things like the faculty suite, but I just couldn't do anything with them. And it looked like my linear algebra class wasn't going to make it. But then this morning when I came in, because I didn't check yesterday because we were in the air just about all day long yesterday, you're in linear algebra also. It's up to 6 students also. Now, whether they're going to let it make or not, like I was talking with you before, if we don't get enough paid students in there, it's not going to make. Okay, they won't let it make. So about half the class is not paid now. So if they'll pay, and especially if at least one student in there is a Lawson student who has to have it to graduate, then I can get by with arguing, let me teach the course. They won't pay me for it, but they'll let me teach it. Okay, and that's the deal with this class. Y'all are both transient students. There's one Lawson student. She's not here yet, but she was registered for it, and last spring she registered for it. She was the only one in the class, and I said, could you come in the summer? And she said, yes. I said, well, and she has pre-registered for it, but she's not here yet. So that's, I'm hoping she will show up. Because if she's in here, then I can say she needs it to graduate. It lets me run the class, and then they'll let me teach it and not pay me, but that's okay. I want the graduates, okay? And y'all get the benefit of that, okay, because you get to be here. So I don't know if I'm going to have from 10 o'clock until 12 o'clock open or not, okay? I just don't know, because if none of those are Lawson students, they may not let me keep it open with only 3 paid students. All right, then at 12 o'clock on Tuesdays and Thursdays, I have a physical science class. It goes from 12 to 1:50, and then the lab goes from 2 to 3:30. Then I have another physics class over on the Birmingham campus that goes from 4 until 5:30. It doesn't have a lab with it, okay? It's one for sonography, the students who are going into sonograms and things like this. They just need a little bit of physics with no lab. They get the labs in their other courses. So I have very few office hours, especially if that Math 237 makes. Then I have 10 minutes here, 10 minutes there, and almost no minutes after that, okay? Another 10 minutes, okay? On Mondays and Wednesdays. On Tuesdays and Thursdays, and that includes my lunch, by the way. I eat my lunch in those 10-minute periods in between classes. All right, on Tuesday, Thursday, if they let the linear algebra go, then I'll have, I said that wrong. On Monday, Wednesday, 40 minutes, 40 minutes, 10 minutes, 10 minutes, okay. On Tuesday and Thursday, it's 10 minutes. If that linear algebra goes, it'll be another 10 minutes. Let me back off. The Physics 202, if we don't get more students in it, then I'll have a big chunk of office hours then. So that'll be my office hours, okay? And that's when I'll eat lunch, at 2 o'clock in the afternoon, so that'll be fine. Tuesday, Thursday, if they don't let the linear algebra go, then I will have 2 hours office hours from 10 to 12. But other than that, just 10-minute periods here and there. And one of those, the 30-minute period I have, I'll be driving to the other campus, so effectively no office hours there either. Okay. And then Fridays, when we have Fridays, I'll be on Birmingham campus, probably 7:45 till 11:45. Tomorrow I'll be longer because this has been a short week, so I'll be a little bit longer, but I probably won't be a full 8 hours because like you see today, I go until 5:30. And so 7:45 to 5:30 is already 8 to 5 is 9 hours. Is that right? Yeah. So 9 hours and 45 minutes. So I'll be an hour and 15 minutes short of 8 hours on tomorrow. But I'll probably be there longer anyway. So those are my office hours. Sorry I didn't get these corrected, but that's a general idea of when I'm on campus and when I'm not. Okay. Course of instruction. Now this is not, or course description, this is not something I came up with or anyone here at the college came up with. This was a result of a committee of 2-year college math people and 4-year college, University of College, State of Alabama math people said, if we do this, you get credit for it. Okay? So that's why you can take it here. Introduction to numerical methods, qualitative behavior of first-order differential equations, techniques for solving separable and linear equations analytically, and applications to various models, as in population, motion, chemical mixtures. They put all this stuff in, but yeah, okay. Techniques for solving higher-order differential equations with constant coefficients, the general theory, undetermined coefficients, reduction of order, method of variation of parameters, with emphasis on interpreting the behavior of solutions. Okay? And applications to physical models whose governing equations are of higher order. Okay, that's all part of this higher order. Laplace transform as a tool for the solution of initial value problems whose inhomogeneous terms are discontinuous. So far, I've not been able to get that far. This is so much to cover here. I've not gotten into the Laplace transform, and that's sort of listed at the end, so I sort of take that as sort of optional. I hope it is for your future sake. Okay. By the way, what are your majors? Mechanical? Electrical? Civil? Okay. Now, I don't know everything that you do in those, but the most people that use the Laplace transforms are the electrical. That's what I thought you said electrical. I said, oh! No, but they are the ones that, as far as I know, use Laplace transforms more than the other. You may have applications in mechanical, but I can't think of any, and I can't think of any for civil either. So, but there may be some. Okay. Prerequisite is Cal 3. Both of you had that already? Okay, good. Prerequisites, none. Let's see if I can get the textbook to come up without, yeah, okay. Here is a textbook. Okay. First course in differential equations with modeling applications. Okay. And this is the 13th edition. Now it seems, no, 10th, okay, sorry. This is the 11th edition, so I have to get that corrected. So, have y'all gotten it yet, or are you going to do an ebook, or I don't even know if ebooks are available here. This is a book that's published by Cengage Learning. Now, I do not care for the company in general, but this is a book that most of the other two-year colleges that I've spoken with, their instructors, they use for differential equations, so that's why I went with this one. It's a decent book. But why I mentioned Cengage Learning, sometime or another, I don't know if it's starting this summer or if it's next fall, but sometime or another they're starting this program that for $119 or something like that, you can get all your books for the term for that. So you might want to check, if you are going to buy a book, check at the bookstore and see if that's in effect, because I bet you this book by itself is more than that. Now, whether that's a rental, I don't know any of the details of it, but they've come up with that, and they're wanting us to use all the Cengage books we can, which I think is a gimmick, because not all of them are the best books out there. But this one is a good book. Okay, so there's your text. It's 11th edition. It's by Dennis Zill. It has a more recent copyright date. Graphics calculator, not absolutely required, but if you need one, you probably already have one if you've needed it before. Paper, graph paper, and pencils. Now, if any of your tests require graphs, I'll provide graph paper if you need it. If you have your own, you can certainly use that. Someone else wrote this syllabus. They specified pencils. I'll make a little confession here. When I do math, I tend to make errors. So I like to use pencils so I can erase and get it going. Not any ink blobs all over the page. If you prefer ink, it's fine with me. I don't take off anything. Okay, then Blackboard. All Austin State Community College students must be trained in Blackboard to use Blackboard daily to gain access to vital course information such as the syllabus. And you are going to read the syllabus every day, aren't you? Weekends included, right? Of course you are. Not making fun of this. This is a little bit overstated here. Handouts. Usually if I have a handout, I'll hand that out to you, okay? So I don't usually put those there. PowerPoint shows, okay? Now, one thing I do not like about this book, they don't provide PowerPoints with the text. So I don't have any PowerPoints. So there are no PowerPoint shows for this book. However, like I described before, I will be using Screencast-O-Matic, and that will go to YouTube, and you'll have a link in YouTube to be able to follow it. So you will see everything we've done. It won't be as pretty as PowerPoint because I'm having to write it all. Okay, and that's where the book comes in really important. So what are your plans for a book? E-book, or not use a book, or just use what I do in class? E-book. Okay. Not a bad idea, because otherwise I have to write out every theorem, and then you reading my writing, you'll attest to this one, so you better not. Okay. It's not that great. Okay, she's been in one of my two classes before. Okay. Activities. Now, sometimes the school puts activities out there, and if so, you might want to know what those are. So check Blackboard for that. Assignments, I will have at least one assignment up there, and we'll talk about it next. This course does require, a research paper, okay? So that assignment will be there. It's not there yet, just like the syllabus isn't there yet, okay? Now, the assignments will be there because at the end of every section, and maybe at the end of every class day, I'll go to the exercises at the back and say, these are good exercises to do. But you'll hear those through the through the YouTube videos, I don't type them out and say, here are your assignments. Okay, they are there, but it'll be through YouTube. And by the way, let me say this. If that linear algebra class makes, like I say, I have 10 minutes here, 10 minutes there, 10 minutes somewhere else, I'm driving, so I'm not going to have time to upload the Screencast-O-Matic onto YouTube unless one of these classes doesn't make. I don't have any time during the week to it. So maybe when I get home at night, I'll be able to do that, or before I leave campus, or if I come in early, get it done, or Fridays, okay? So I can't guarantee they're going to be up there. It will be uploaded to YouTube, but I won't have it in the playlist because it takes me time to go in and move it around and do all that kind of stuff, and I just don't have it. Now, if that physics class doesn't make on Mondays, then I'll have time to get it caught up on Mondays and Wednesdays. If the linear algebra doesn't make, I'll have time to get it done on Tuesday, Thursday. But other than that, that's going to be tough to do. So, but those will be there. Assignments, okay? Announcements, okay? A lot of times the school puts announcements out there. Most of the time I don't, unless something comes up that I haven't had a chance to announce it in class, or not many people were here to hear the announcement. For instance, I'll give you this one now, okay? It doesn't affect this class at all, but it does affect my office hours, those little 10-minute periods, okay? This next Tuesday, this coming Tuesday, June 5th, is that right? Yeah, okay. This isn't adding up. I'm going to have to check on this. I have a doctor's appointment on June 5th, but on the message that was on my phone, they said Tuesday, as if this coming Tuesday. This coming Tuesday is not June 5th, is it? Today's the 24th. 25th is tomorrow. Well, yesterday was 23rd, so next.
It's Tuesday, the 29th.
Second?
It's Tuesday, the 29th.
Is the 29th. And then the next Tuesday is the 5th. So I'll have to find out. I need to find out before my next class, because I'll tell them. Because there was a message on our phone when we got back last night. You have an appointment at exactly this time, exactly this place, everything else. But they said Tuesday, but they didn't give a date. I thought that was bizarre. Okay, I'll find out there. But here's the deal on that, and I'm sorry, not that you need to know it, but I have a mild form of leukemia, so I have to have treatments, and I have to see my hematologist every few months so he can monitor how things are going. And he only sees patients on Tuesday mornings, so I can't avoid a Tuesday morning thing. I did put it at this time because I wasn't sure the linear algebra was going to make, so I put it at that point. So this class is good for whatever Tuesday it is, I'll be there. The linear algebra will not be good for that day. Okay. So anyway, those kind of announcements I will put there when they come up, and especially if I have had a chance to do it in class. Grades I will put, and these are on Blackboard, as soon as I get them graded. But as you might imagine, I don't have a lot of office hours to do grading, so I'll be grading in the evenings, I'll be grading on weekends, I'll be grading whenever I have a chance to grade, Fridays when that's possible. So I'll get them there as soon as I can, okay? So I like to promise within a day or two, but I can't say that for this summer unless one of those classes don't make it. Now, I do not like this next sentence. Failure to use Blackboard can severely damage your ability to pass the course. That to me is way overstated, and it's so negative. If they allowed me to change it, and they don't allow me to change this paragraph, I would say the proper use of Blackboard can greatly enhance your ability to do well in the course. Much more positive, I think, closer to the reality, okay? See the schedule book. We haven't had a schedule book in years, okay? But they haven't changed this, and they tell us we can't change that paragraph. And then this next one, students should always check Blackboard announcement page prior to coming to class. Why do you reckon they would put that in there? To me, the only reason would be comma in case the class is being canceled, right? Okay, that's the only reason I would think they would say you should always check Blackboard announcement page prior to coming to class. Well, I'll tell you now, unless an emergency comes up, I'm not going to cancel class, or a doctor's appointment. I'm going to let you know well in advance of that. So to me, this is almost an insult. This is just like, yeah, and maybe some instructors do cancel classes on the spot. Only time I can see that happening if I got deathly ill one morning, and guess what? If I'm deathly ill, I'm probably not going, oh, let me get it on Blackboard and cancel, do an announcement. Or if there's a traffic jam, and this morning there was one, but it cleared up, and I was way early, so I still got here, in plenty of time. But if there's a traffic jam, I'm not going to be able to get on Blackboard and put an announcement there. I will call somebody, and they'll put a note on the board for me. Okay. If I remember to bring my cell phone that day. I have a bad habit when I charge my cell phone overnight, forgetting to pull it off and pick it up. So anyway, student course learning outcomes. Students will be able to find solutions of first-order differential equations, including separable equations and linear first-order equations, and applications of various models. Okay? Students will solve linear equations of higher order, not just first order, but higher order, including equations with constant coefficients and undetermined coefficients. Students will use Laplace transforms, we may not get that far, methods to solve initial value problems with continuous functions. Okay? Students will use numerical methods to approximate solutions to systems, and students will research and write on the topic of differential equations. That's the research paper. Okay. Now, those are the student learning outcomes. Let's look at the competencies that correspond to those outcomes. Okay? Now, here I wish you had the book, but since you don't, I'll paste through them myself. Chapter 1 is Introduction to Differential Equations. Normally, I'd say read that on your own. But that has so much nomenclature in it that we'll be using all term. If you don't understand the nomenclature, you won't know what I'm talking about. So we will go through that fairly quickly and do section 1.1 very quickly, hopefully, and I don't do anything quickly. Initial value problems 1.2 and differential equations with mathematical models. I'll probably not do too much in that, okay? Even though modeling is one of the things, well, it doesn't really say that, does it? So yeah, we'll probably do, yeah, there, the very first one, various models. Okay? Chapter 2, though, is first order differential equations. And I can't remember. And we definitely will do that. So first order differential equations. And chapters 1 and 2 will be what you cover on the first test. Okay? And we may not do every section in that, but we will do 2.1, which has two subsections, 2.11 and 2.12. Separable equations is 2.2, linear equations 2.3, exact equations 2.4, and solutions by substitutions 2.5. I can't recall if we do all of 2.5 or not. We may not. That's going to be chapter 2 then. Chapter 3 is modeling with first order differential equations. Okay? And what we're going to do is, on the models is just do them in the chapters, not do a whole chapter on it. So we skip 3. We go to 4. Higher order differential equations. That's topic 2 there. Linear equations with higher order differential equations. Okay? And we won't do every section there. Some of these are optional, and so we'll do the ones that we can, that we have time for. It's 10 sections with several subsections, so we'll only do certain ones of those. Plenty to do a test on them. Okay, I'm sorry, chapter 4. Chapter 5, again, is modeling with higher order differential equations. We'll probably do a little bit of that as we go in Chapter 4. We won't do a whole chapter in Chapter 5. Series solutions, that's nowhere in the course description, so we skip Chapter 6 as well. Laplace transform methods, that's what we'll do if we get time to do that. Okay? Systems of higher order differential equations, we're not going to be doing that. Systems of equations and numerical solutions for ordinary differential equations. That's here, but again, we find that numerical, and there's numerical methods here. Now, sometimes, actually what we do, they have some of the numerical methods in the earlier chapters, and then we'll just refer to Chapter 9. But most of those will be in the earlier chapters. You will have the research paper, and we'll talk about that in just a minute, and the overall competency is the final exam. But every time I've taught this, especially in the summertime, we don't have time for a comprehensive final exam. We just do the last test. But of course, the last test builds on all the other chapters. So it's sort of like a comprehensive, but it won't cover all of them. Now, there's probably a good place to stop and ask this question. Do you prefer in-class test or take-home test? Take-home. Oh, wow. It's amazing. I'm so shocked to hear that. Okay. No, that's what I usually get. Small classes like this, which some of the problems can be sort of involved, I don't see restricting you to a certain time period for that, nor do I see taking a whole class period just to do a test. So I prefer doing the, especially upper level classes like this, to do the take-home test. Because in reality, when you're out in the field working as an engineer and you have a problem, you need to use every resource you can get to help you solve that problem. Okay? So why have an in-class test and say you only are required to do what you memorized? That to me is ridiculous. Y'all take the PE exam at some point, right? EIT before that? Or they have some other name for it? You don't have to. Okay. But if you continue in your field, the odds are you will at some point. And guess what? You can carry any book you can haul into that exam. Because if I were your employee, I do not want you counting on memory. I want you looking things up. Even equations. I'm pretty sure I know every detail about that equation. Well, the Pythagorean theorem, those kind of things, everybody knows. But any complicated thing, I don't want you, is that a plus or a minus? I think it's a plus, No, I want you to know what that sign is. Okay. So I'd say your test will be take-home. And that's why I said that last one will be compiling all the others. I won't give you one on the last chapter and then turn around and give you your final. We'll just go to it again. Evaluation and assessment. The grading pilot or research paper is required. Notice that's not optional. Required for the course. It will count as a test grade that cannot be dropped. Okay, it's required. The reason is SACS, our accrediting agency, periodically will sometimes ask for, and others too, ask for samples of student writing. And they like to see that in fields, not just English classes. Okay, so that's why I do it. Tests will be given after each unit as indicated here. The lowest test score may be dropped. The reason I put may rather than will, if you don't turn in a research paper or turn in a really lousy one, which I can't imagine students at your level doing, and it's a really lousy grade, you'll need every test score you can to pull up that lousy grade. So only if it helps you will I drop a test grade. Final exam cannot be. That means the last test cannot be dropped. You have to turn in that last one. And each assessment will count as on the 100-point scale. Okay? And that scale goes as I think you're probably used to, and Lawson uses this too. 90s are above are A, 80s are B, 70s are C, 60s are D, don't go there, and 59 and below is F, don't go there. Okay? Especially with take home, got plenty of time to work on that research paper, go for it. Okay, attendance. Students are expected to attend all classes for which they're registered. I know sometimes you can't, okay? That's another reason I report the classes. Students, and especially in the summertime when people have things already planned, like my wife scheduled this trip to Europe, and I didn't know she we weren't coming back until yesterday. I thought we were coming back the day before, but she couldn't get everything arranged that day, so she went for that. But if you can't attend it regularly, regardless of reason or circumstances, consider withdrawing before you get into the 60s and 70s, or 60s ranges and below. Because you as transient students, I do not believe they'll take a D or an F. I know they won't take an F. I doubt if they'll take a D from here. Okay? I don't think it'll be a worry for either of you. Stay up here. Okay? But consider withdrawing before your poor attendance interferes with your ability to get a passing score. I don't know what kind of financial aid you may be on. Withdrawal can affect that, but I doubt if it's going to be appropriate for y'all. Withdrawal from class could prohibit you're not in nursing allied health, so that's beside the point. And it says before withdrawing, see your advisor of financial aid office. But here's the deal. I don't know if you're on financial aid or not. Any that may be in the class that are. Financial aid will usually let you repeat a class once. Okay? Now, you make a D in a class, you have to repeat it. They'll let you do it once. Make an F, they'll let you repeat it once. Withdraw, they'll let you repeat it once. So everything's the same for those three as far as financial aid goes. The difference is these two hurt your grade point average. A W does not hurt your grade point average at all. Okay? So there's no reason if you, and this is not for you, but for others, if you have a D or an F going in, and our last stage of withdrawal is pretty late in the term. Going in that doesn't look like it's going to be much chance of you getting better than that. Go in withdrawal, okay? There's no advantage to getting something that hurts your grade point average rather than something that will not hurt your grade point average. Okay. If you have to do it the second time you repeat, not going to pay for any one of those either. So there's no difference. Makeup work assignments should be submitted within 1 week of the day they are assigned. I'll give you at least a week to work on the test. Usually you can have longer. There's that last test, I have to have grades in, so that's why the week is in there. But the others, you can. If you cannot hand in your assignment within that time frame, please let me know. So it's no problem if you need more time. I just don't want you not having to turn in the first test when I've already given you the second test. Get it done before the next test. Okay? You will be allowed to drop one major test, not counting the paper or the last test. Okay? Lateness, we'll try to begin at 8. Again, traffic may bother that, other things, but I'll try to be here. Like this morning, I was here way early, and still we were barely able to get started at 8. Everyone expects you to arrive prepared, blah, blah, blah. Okay. Discrimination and harassment. Hopefully you've seen, if you've not been here at Lawson, you've probably seen it in your other courses. Let me just summarize this. We don't condone it. We don't tolerate it. We deal with it quickly. We don't want it happening here. And so far I've been here, this is my 21st or about to be my 22nd year here teaching, almost in this classroom all the time, but not always. But I have seen very little to none that would qualify here. I've heard about a little bit, but I've not seen it myself, okay? One time there was a kid, now we get a lot of young kids in the career technical area right out of high school, and they really aren't interested in college, but their parents are making them go to college, so they have to take something. One kid in the automotive program decided at lunch one day to walk on people's cars out in the parking lot, just step from one car to the other because they're parked right next to each other. He was yanked off, sent to the dean's office, and I don't know how long he was in there, but he was never seen again. No, I mean, he was off campus. I don't know if that would fit under discrimination and harassment. To me, that just fits under stupidity. But anyway, he didn't come back. Now, we give everybody a fair shake. We listen to everything, but we do not tolerate harassment. Now, I include in this bullying. Okay, any kind of discrimination or harassment, bullying, anything that would fit there. Okay, now, because I haven't seen any, doesn't guarantee it hasn't happened. Okay, I didn't see the kid walk across the cars. I heard about it later. But if you see or even sense there's something like this going on, please let us know, because we do not want it happening on our campus. So please let us know. Okay. Enough of that. Okay. Americans with Disabilities. This is another thing that they don't want us changing anything to this, so this is how it reads. Federal law, and it gives a couple of the acts here, requires accommodation. And I'm pretty sensitive to this because if you haven't noticed yet, I talk too loud, and that's because I don't hear well. And I've asked you to repeat something, probably already, because I don't hear very well. So I'm fairly sensitive to this. If you feel like you need accommodation based on anything, it could be physical, it could be all those letters they have, HD, whatever those letters are, I don't remember them all. But we have two professionals on campus and other counselors as well. Dr. Renee Herndon is on this campus, and she's in charge of the Office of Disability Services. Ms. Janine McCoy Jones is on the Birmingham campus. Please see us, email them, call them, whatever it needs, get the process going. I cannot assume that you have a disability, because if I do, I've just discriminated against you. If you didn't, I mean, I've made that assumption. So I cannot assume that. You get the information to them. You bring it to me, I'll get it to them, okay? But they have to make the contact, the decision on that. They're the professionals at it. Here on this campus, in this building, first floor over in the Student Services Wing, is Miss Dr. Herndon's office. On the Birmingham campus, that's on the Space Center in the Leon Kennedy building, second floor. Now they're working on a brand new building over there, but it's not going to be done this summer, so that's going to be where it'll be, on the Birmingham campus. Okay? This is not the course calendar for the day. This was last fall. I'll get this updated, but there'll be dates in there, and you can see it on the website, basically. Go to academic calendar. When you go to the Austin State webpage, there's a whole bunch of blue tabs at the top of the thing. Look for academic calendar. Click on that. You'll see all this. But I will fill it in to this template here, and it'll all be out there. Okay? And then finally, there is a form for you to submit. Woo! I've got the syllabus out there. You've read it. You understand it. If you have any questions, please ask me. Then you can either print this off, sign it, and give it to me, or you can just type your name in there and email it to me. Either one you want to do. Hey.
Can I call you when your class is over? I was trying to fix my hand.
I'm sorry, I can't hear you.
Can I call you when your class is over? I was trying to fix my hand.
Trying to do what? I'm hard of hearing. Sorry.
I was trying to fix my hand complete.
Oh. Okay. Yeah. Okay. I've got 10 minutes between this class and the next one. Okay. That's 10.
I emailed you too. So.
Okay. Yeah. Well, I've been out of the country for more than a week. Okay. Almost 2 weeks.
Because they told me I can't start my summer classes until I fix it.
You can't what?
I can't start my summer classes until I fix it.
Okay. What was it that you were missing? You know?
I think it was all my tests.
I'm sorry?
It was all my tests.
Okay. Well, yeah, that's a lot to fix.
Yeah, I know.
Okay. Well, I've got 10 minutes between 9:50 and 10 o'clock, and then from 10:50 until 11:50 to 12 o'clock, another 10 minutes, and that's all the time I've got today. Yeah, so catch me right after this class, 9:50.
9:50.
Okay.
Thank you.
Uh-huh. All my tests. Okay. I need it now. Okay. All right. Any questions so far on the syllabus? Okay. Then let me go on and get out of here. Boy, this is slow today. Okay. For some reason. Okay. I don't know why it's open twice. Okay. Let me go to this. Here's the research paper, and I'll try to do it quickly. Like I said, I don't do much quickly though. Okay. Okay. General instructions for it. Okay? You get to choose your topic. Any topic that you want to that's within the scope of this course. Has something to do with differential equations. Okay? It can be a person. We will run into a few. You may have seen some in some of the titles. No, you didn't get to see the titles. Well, I did. But when you get your book, you'll see Runga Cutter. You'll see all sorts of different things. It could be a theory. We'll have lots of theories mentioned. A few of them are pretty major. It can be a phenomenon that is associated with differential equations, and there are plenty of those. It can be an application, and these I really like to see. If you in civil or mechanical engineering know of a problem or a thing that can be described, defined, and solved only through using differential equations, and I tell you most of them are like that. You may not realize they're using differential equations because you may have tables and charts and things that you look up. Guess where they got those? Differential equations. So if you have applications of differential equations in your field of study or in any interest of yours, you can do on that. Any other topic which you have an interest. Now, I put this in a few years ago, or it can be an internet application or demonstration, think YouTube video or something like that, that describes or explains or carries out something that's mentioned in the book, and you say, I don't know what they're talking about. I talk about it, you say, I don't know what he's talking about. But you find something out there that really opens it up for you. Yeah, I want to see that, okay? And you can write your paper on that. What was it that was missing here or missing here that made it clear when you went to this? Or if you compared several sites, you couldn't find anything here, but this site really did it well. Yeah, you can do a paper on that. So it can be based on the internet. You still have to write the paper, but it's based on the internet application or demonstration. You just tell why you found it useful, what features were. Now, what I'd like you to do, either today or by next week, okay, is write your name, that's pretty easy, and a topic that you would like to investigate on a piece of paper and turn it back to me. Okay, now that's a lot to put on, very little to put on a single piece of paper, okay? So let me give you a couple more things that have nothing to do with the research paper here. I don't know, I know I've been in touch with you before. Have I on phone too? Yeah, okay. Have it with you. Sometimes the people that enter the stuff from your application invert digits or reverse digits or something else, and sometimes the numbers we have in the system we can't get to students, okay? And so if anything were to happen, and it doesn't happen often. In fact, I don't think it happened at all last term. But I have had some terms where I got just a panicky type phone call from some administrator somewhere. This is so's in your class. The number in the system's wrong. I need to get in touch with them. Okay? Well, if you want to give me, since you're writing your name and your paper topic on a piece of paper, if you want to give me your very best phone number, it's completely up to you. You don't have to, but if you want to give it to me, you can. Now, if that very best phone number, I'm just going to make a guess, it's going to be that cell phone, right? Okay? If there's a chance that could be left at home, the battery died, you got run over by a truck, or something else could have happened, and we can't get in touch with you that way, and you want to give me a good backup number like Mama's landline or something like that, you may if you want to. You don't have to. Or, and I don't know if either one of you work, but if that happens to be, we have a lot of students who do work when they're not in class, like maybe work Monday, Wednesday, and then class Tuesday, Thursday, or something like that, and they don't like you to use your cell phones there, if they do allow you to have incoming calls there for emergency type situations or something like that, and you want to give me that number, you can. I can't think of any reason I'd need more than 3 numbers. I don't need any of them if you don't want to give them to me. But you can do that if you would like. I do need your name and your paper copy. Okay? You'll need to find at least one, but 2 or more are better, outside sources for your paper. Even though this may have some good little descriptors in it every now and then about some historical context and stuff, this is not an outside source. You have to get something outside the course, outside the book. Okay? That could be a book, a journal, an article, a newspaper, magazine, anything that you can find in the library, or, and this is the big word here, any legitimate source you can find on the internet. I know a lot of places and courses don't want you to use the internet, but there's a lot of really good stuff out there The trouble is you don't know which is good and which isn't. If you have any doubt, find something else, okay? Run it by me. I'll say, oh yeah, that looks good. That looks legitimate, okay? Textbook is not an outside source. Your paper must be at least one word process page of text. Double space though, okay? 12 point or 12 pitch, whatever you call that, fine, okay? Now, what do I mean by one page of text? I don't care what format you use when you're writing this, but a lot of students will have some format. They give some sort of header up here, maybe there, skip a few lines, and then you have your title, skip triple space or something, and then you finally start typing right here, okay? One page of text is going to go to the bottom of that page, and on the second sheet of paper, go down at least that far. That's a page of text. It's going to be at least 2 pieces of paper, by the way, to be one page of text. Because you're going to have a title or something, my guess is you will. Okay, so 1 page of text. Now, that includes the double spacing. That's fine. I want that double space. It's easier to read and mark. And 12 pitch. This is 12 pitch font here. I don't want any 26 pitch that 4 words fill up a page and say, I'm through. No, you're not. You know, that won't work either. Okay? The font you use is up to you. This happens to be Arial. Okay? I like Arial. Times New Roman, most of the word processing packages default to that. That's fine. Courier. There's tons of good readable fonts out there. I don't read hieroglyphics or Old English or any of these really fancy curly Q things, Cyrillic or any of that. Keep it something that's good and readable. Okay? Now, I say try to keep the paper less than 2 pages. Okay? But if you get so excited about your topic and you got that to write much to write about, fine for you to go over. You get penalized if it's too short. You don't get penalized if it's too long. But I've had this happen too. And again, not very frequently, but I've had it happen maybe 2 or 3 times that someone thinks, well, if I can't give them quality, I'll give them quantity. Okay? So they give me page after page after page of really lousy paper. Okay? And I just say this, and I don't do this because of it, it's just how I grade the papers. When you turn them in, they're 100-point paper. And then when I go through grading and I find errors and things, you start losing points. So a 15-page lousy paper is going to lose a lot more points than a 2 or 3 page really good paper. It's not going to lose very much. So I don't want you trying to replace quality for quantity, quantity for quality. I want the quality. And if it's a long paper, good quality, you're not going to lose many points, okay? So don't. And like I say, very seldom have I had that happen, but I have had it happen a few times. And those are really miserable to read, although I do read them all. Okay. You may use any standard format you want. Most English classes teach MLA, Modern Language Association. But a lot of science areas go with APA, which is American Psychological Association. They just came out with a real good format many years ago. Everybody said, wow, this is good. Why recreate the wheel? You know, we're going to use this. But if your particular area or field and your other courses use some other format, I'm happy with that. It doesn't matter. However, the important thing here is be consistent with your format. I chose to block my paragraphs. So if you choose to block your paragraphs, block them all. I've had some papers come in, not very often, but occasionally. They'll block the first couple, indent the couple, indent a different indentation. Yeah, that is just inconsistent. Okay? I want consistency. Okay? Another thing, and this does happen a bit more frequently, let's say you have a couple of different sources, 3 or 4, whatever. I've seen this happen. I think I know exactly what's happening. Now, I understand that you have different ways to reference books and journals and articles. They all have different things in every format that's like that. But I've seen the same thing referenced. And up here, say in this paragraph, they'll open parentheses, put name of the author, comma, year of publication, blah, blah. And then down here, they'll do the same type of a citation, put the open parentheses, put the title of the article, comma, page number, or something like that. Now, I think I know what happened. This book they were referencing up here used one format, and they used that format for that book. This one down here was using a different format, so they use that same format. No, you choose your format, and then do all your citations by that format, not by the format of whatever source you were using. So that's what I mean by consistency, okay? Be consistent. Spelling, grammar, sentence structure, all those kind of errors cost you points, so please use spell check. There's no reason not to. Just about every word processing package has it. They sometimes will have grammar check. Most of them, I think, have that nowadays. So use those, okay? Also use good proofreading, and hopefully you run into that in other courses. But it's not just that. Content also matters. And I'll just give you a few dumb examples. I've had before, say, Isaac Newton, he's a favorite of a lot of math and physics classes. They'll write about him, they'll give very beginning when they say his name. You don't have to do this, so they chose to do it. Year of birth and year of death, you know. But then here on page 2, they have him dying a different year than he was on page 1. And it may have been a boring paper, but it wasn't. No, I'm just kidding. That's just inconsistent. I've had people write home, and this is in lower level courses, of course, Pythagorean theorem and state it just totally wrong, or their examples are wrong, or something. So content also matters, okay? So if you have inconsistencies there, you'll lose points in it. Paper is due by the last day of class, but that's not the last day of the final exam. This is the last day that we're in class together. Okay, so that's usually right at the end of July, I think. I think finals are the first week in August, but if we go into August, then I haven't done my calendar yet, so I haven't figured out what day that is. But that's when it's due. But please don't wait till the last day to turn it in, because guess what? You'll never have more time to work on the paper than you do right now. I don't know what else you're doing this summer, but in this class, in a few short time, because it's 10 weeks. We only got 10 weeks. You're going to have the first test and the second test and third test. Yeah, the tests are going to be coming. If you're taking any other classes, doing any other things that could all pile up and bind up, you'll never have more time than you do now. Get started. That's why I want you to turn it in early, so you can already get thinking about it and get it done. Okay? Now, as I said before, you'll lose points if maybe I didn't say it. Let me say it now. Lose points if it's turned in after that last day of class. This course, Tuesday or Thursday, the last time we meet. If it's turned in after that, you lose points. That's the stick. Here's the carrot. If you I've got to get this worked out. If you submit it in the month of May, which we're in right now, and there are not many days in May, but there are a few left, you're going to get at least 2 bonus points, okay? You turn it in the month of June, you'll get 1 bonus point. And if you turn it in before that last week of class in July, let me go back and say that. Month of May, 3 bonus points. Month of June, 2 bonus points. The month of July, not the last week of class. Before that last week of class, you'll get 1 bonus point. If you turn it in the last week of class, you'll get the score you have for the paper. Okay? That way, whether it goes into August or not, that'll be covered. July before the last week of class. Okay? Now, here's one other thing. Most instructors don't require this, I do. When you submit your paper, please attach a single page from one of your sources. You have 5 sources. I don't need a page from each source. Pick a source. Give me 1 page. I don't need the whole source. Just a single page from one of your sources. Turn that in with a completed paper. If you don't, you're going to lose some points. Okay? Any questions about the research paper? I'll get the other things correct. The only thing I have to do is figure out the months and get those done. Thank you. Okay? Any questions? Okay, I'm going to leave this up here for the next class, and if you're the only one here, I won't repeat it again, okay? So I'll leave that alone, and then go to this. And this is just an example. This was last summer. This summer, I'm usually here by 7:45, so you have 15 minutes before class. On Mondays and Wednesdays, I have Math 125 and 126, so those are the same as before. So you see, I only have actually 10:40 to 11 o'clock lunch. That's all I got. Okay. This goes until 1:40, and you'll see, 1:45. There's my lunch again. You know, I'll eat a little bit in between each class. Then my physics class starts, if it makes. Now, this time it's 202 is first and 201 second. We alternate, you know, that. And the 202 is the one that's short now. So all these may be office hours in here, okay? But if that does make, then I'll be occupied there. The 202, I think, has made, or it looks like it will make, and that goes until, I'll have to check, but the time may be wrong. It's either 9 or 9:15. So anyway, going to be long days on Mondays and Wednesdays. On Tuesdays and Thursdays, again, like I've already said, I'm here by 7:45 most days unless there's bad traffic or something. And then this class goes until 10:50. And I put down office advising. Oh, the linear algebra didn't make it last summer, so I did have that time in there. But Physical Science 111, that one's made already, and that's going to go from, whoa, goodness gracious, where did that go? Okay. That goes from 12 o'clock to 1:50, then the lab from 2 until 3:30, and this is 3:30 now, yeah. And now I don't have office advising then because I picked up a 4 o'clock physics class on the Birmingham East Campus, and that goes until 5:30, and then I'll probably be on campus till 6 o'clock. Maybe 5:15. No, maybe 5:30. So that's going to be it. Fridays are only going to be in existence tomorrow, next Friday, and then any Fridays in August. So any questions? Okay. I'll leave that up for the next class as well. Okay. I do need to do one more thing. I forgot to do. Why that opened twice, I don't know. Well, I think I do know because it didn't. Let me get this opened. I forgot to do that earlier. Now, this is an unbelievably small file, and it takes forever for it to open, and I do not know why. Since we're waiting for it to, oh, here it comes. Do you know what I just did, folks? When I went on break, I paused it to take it off till just then when I hit the wrong thing. Anytime something happens, and sometimes when students come in, I'll pause it. I didn't last time, but I forgot to take this out. Sorry, folks. That part wasn't recorded. Yuck. This is what I was trying to do. That I wrote a D, but it should have been a partial. I've heard those called dells, but a del is a gradient. That's what a del is. I've heard people call those dells. I don't know what they call them. That's a partial differential equation. Or even as simple as partial of u with respect to y is equal to the part minus the partial of v with respect to x. Again, partial differential equations, we're not going to deal with these, okay? But you do run into them, okay? But you run into them when you have more than one independent variable and you're taking derivatives, and you have to take partials. If you have the same, only one independent variable, then even if you have multiple dependent variables, you can take ordinary derivatives because it only has one dependent variable. Okay. Now, again, this is going back to Calculus 1. So far, we've been using what they call Leibniz notation. Okay? That's L-I-E-I. Now, one reason I write that down is because if you want to write on Leibniz, you can. Okay? He's mentioned there in the text. Okay? In Leibniz notation, now, we're going to go back to ordinary right now. We talk about dy dx. We talk about d2y d2x, dx squared, I mean d2y dx squared. We talk about d3y dx cubed. You know, you can talk about all sorts of things. That's Leibniz notation. Now, quite often differential equations are written in your book and otherwise like this: y prime, y double prime, y triple prime. And they just call this the prime notation. Okay? Now, a lot of times it's going to be useful to use Leibniz notation rather than prime notation. One of the things that's missing in prime notation, you don't know what the independent variable is. You know you're taking the first derivative of a dependent variable, the second derivative of a dependent variable, or the third derivative of a dependent variable, but you don't know what the independent variable is unless you see it somewhere else in the equation. Then you have to make the assumption that's the dependent variable, independent variable. There it's obvious. It's x, it's x, it's x. Okay? If one of those was a t, then it's t. But you can't have an x and a t in the same one before you start going to partials. You can only have one independent variable to use Leibniz or prime notation. If you have more than one, you have to use partial notation. Okay? So this is only for ordinary differential equations. Okay. So if you had, I've already erased them, sorry that I did, but if you have your notes and you had the dy dx plus 5y is equal to e to the x, that could have been written as y prime plus 5y is equal to e to the x. Okay? Now, again, you make the assumption here, you don't know what this is with respect to until you see that x there, and then you have to assume that's with respect to x. Otherwise, the problem makes no sense. Okay? If you're using a prime notation, which indicates ordinary, then that other variable has to be your independent variable. Okay? The other one we had there, remember d2y dx squared minus dy dx plus 6y equals 0. That could be written as y double prime minus y prime plus 6y is equal to 0. And in this one, you don't have a clue what the independent variable is. It could have been a t, it could have been x, it could have been z, it could have been p, it could have been anything. Okay? Now notice here, folks, and hopefully you'll never have occasion to do this, but don't use the letter d as a variable, ever, because then you have d, you know, you don't really want that. So just don't use the letter d as a variable. Just like any other letter could do. But here you don't have a clue what the independent variable is, whereas in Leibniz notation you do. Okay? Now, you could have had a third order, like this up here, went to y3, y triple prime. But if you had a d4y dx to the fourth, you don't do y with 4 primes on it. We just don't do that, because after a while you get so many primes, you're having to count that. Is that spot on the page a prime or not? You just don't do it. So this would be y parentheses 4. Okay? You have to do a parentheses, because if you put y to the fourth, that means y raised to the fourth power, y times y times y times y. That's not what we're talking about here. We're talking about derivatives. So anything above 3, which you can use prime notation, above that you use a number in parentheses. Now, it seems like I recall back in earlier life, it seems like they used to use occasionally Roman numerals for upper derivatives. I haven't seen that in years, so I'm not even sure that I'm remembering right. But if you ever see that, try to find out and make sure that's what they're talking about. But usually, modern, you use it in parentheses. Now, a lot of times you'll have, especially theorems and stuff like this, you'll have something written like this: dny dx to the nth. Meaning you're talking about a general derivative. Okay? Well, how you would refer to that in prime notation would be y parentheses n. That would be what the equivalent expression would be. Okay? Because that n could be a very small number, but it could be quite a large number. So you write that as that. Now, it seems a bit late for this, because I've been saying it all along, that they finally get around to showing you which are your things. And since they're showing it to you, I'll do it too. I'm running out of space, so I'm going to erase this and start over again. D2x over dt squared plus 16x equals 0. Okay? Now, all this, they've sort of gotten off track a little bit here, but it's okay. What kind of equation is this? It's a what? It's an ordinary second order differential equations. Ordinary second order differential equation. Maximum derivative is the second derivative, so that makes it second order. It is ordinary because those are d's rather than the partial symbols. Okay? Now, what's a little bit different about this, before, except for one or two examples, we've had x's down here. But if the x is up there, that makes this the dependent variable, that makes the t the independent variable. Okay? Which means this now is dependent. Whereas in the others, if x was down here, if you had a 16x or e to the x, those are still independent variables. But now t is your independent variable, x is your dependent. So it's not always the x. When you see x in a problem, we know it's the dependent variable, the independent variable. Quite often it is. If it's just y's and x's, quite often it's y as a function of x. That's your independent variable. But in this case, it's the dependent variable, and t is your independent variable. Okay? All right. Now, I don't know if any of you are big Newton followers, but Newton made a distinction between a derivative with respect to time as with respect to displacement or something. And he would have called this x double prime plus 16x equals 0. And if in some of your text you run into something like this, when you see the dots rather than the primes, then you know he's talking about with respect to time. The prime he used with respect to x, but it doesn't have to be. But that was an old notation called the dot notation. Some people sometimes called it the fly speck notation because it was difficult to see a prime and whether the mark on the paper was a prime or not. Imagine what the dots were. They could have been swiped. Okay. So, for instance, d2s dt squared equal minus 32. By the way, that looks pretty familiar, doesn't it? Second derivative of displacement with respect to time is your acceleration, and in U.S. customary, that would be minus 32 feet per second squared if you're talking about free fall. So that could have been where you started. When Newton was doing this kind of stuff, he would have called that S double prime equal negative 32, which is a very shorthand notation, but that the dots means with respect to time. Okay. Now, and why they're doing this here, I'm not sure, but they do it because we're not doing it. Partial derivatives, and we referred to some, I'll write down second partial of u with respect to x squared is equal to second partial of u with respect to t squared minus 2u partial of u with respect to t. Okay? Now that is a partial differential equation. We're not really going to do those. But you may have run into this in Cal 3 or somewhere. Okay? And you probably used a subscript notation for this. Okay? Derivatives, we use the superscript primes. You use dots over the the dependent variable, okay? But in partial differentials, you use subscripts. And this would have been u sub xx. The second partial of u with respect to x both times is equal to u sub tt, that second partial of t, u with respect to t twice, minus 2 u sub t. That's the first partial of u with respect to time. Whatever t is. Because remember, you could have, with more than one independent variable, you could have partial with respect to t, partial with respect to x. And that would have been a u. And then you have to reverse these two. But we're not getting into that yet. We're not doing those, but they're just giving you the examples of them so you'll say you've seen it before. Okay. Now, all that was under classification by type, which should have just been really simple, ordinary or partial. But then they threw in all these other ways to write those. Let's now talk about classification by order. Okay, so I think I'll start with a clean page here. Now, I've already mentioned a lot of this to you. Okay? The order of a differential equation, either ordinary or partial, is the order of the highest derivative in the equation. Okay? Now here's an example. d2y over dx squared plus 5 dy dx cubed minus 4y is equal to e to the x. Okay. By type, what type of differential equation is this? Remember, there's only two types. It's ordinary, because those are all d's, no partials. Ordinary differential equation. What would be the order of that ordinary differential equation? Second? Second. Because this is only a second derivative here. The derivative here is the first derivative, is raised to the third power, but that's not a third derivative. It's the first derivative raised to the third power. Powers and derivatives aren't the same thing. So this is a second order ordinary differential equation. Now, been wanting and leaning towards saying something here. This will be a nonlinear, for sure, because this derivative is raised to the third power, not to the first power. To be, yes, sir. Differential equations? No,
Yes, sir.
Yeah.
No, it's linear algebra.
Linear algebra, yeah. Oh, it is time, isn't it? Yeah, I just ran out of time. No, come on in. I hadn't been paying attention to my time. Sorry about that. Well, that's as far as we got today, folks. Sorry about that. Y'all can come on in. We'll start next time with this. Okay, right there. There aren't any homework exercises for you. Well, let's see. If and when you get your books, exercise 1.1, you can do any of the, I think the odds are in the back of the book. Any of the odds 1 through 7. Yeah, and because we haven't gotten into linearity or not. Sorry. Okay. All right, good deal. See you Tuesday. Okay. Now, sorry, I've got to meet with a student for just a moment here, so let me shut this down.